Good morning, everyone. We are Bryan, Wei Xuan, Jaden, and Manish. Today, we'll be talking about the tragic and unfortunate crash of China Airlines 611. Firstly, I would like to give a short background. Next slide. On the 25th of May 2002, China Airlines 611 crashed into the Taiwan Strait, which led to 225 tragic fatalities. The plane model was a Boeing 747-200, registration B18255. It was on a regularly scheduled flight from Chiang Kai-shek International Airport, now renamed Taiwan Taoyuan International Airport, to Hong Kong International Airport, when the aircraft broke into pieces in midair and crashed, killing all aboard, including the pilot and the air stewards. Now, I will pass the time to Wei Xuan that will cover the chain of events.
Thank you, Brian. Now I'll move on to chains of events leading to crash. The flight took off at 15:08 local time, 0708 UTC, and at 15:16, the flight was cleared by the Taipei Area Control Center to climb to flight level 350, approximately 35,000 feet, 11,000 meters, and to maintain an altitude while flying from CHALI direct to KADLO. The acknowledgement of this transmission at 15:16 was the last radio transmission received from this aircraft. 12 minutes after climbing to flight level 350, the aircraft broke up in mid-air and radar contact was lost. Now, I will pass the time over to Jaden to cover the cause of the crash.
Okay, thank you, Vision. Now I will talk about the cause of the crash, which is because of the cracks in the plane fuselage, as well as the poor maintenance, which killed all 225 passengers on board. For the cracks in the plane's fuselage, after more than 2 years of analyzing information gathered from the plane's flight data recorder, air traffic control, wreckage distribution, and a reconstructed section of the fuselage, the Aviation Safety Council (ASC) concluded that a 180.34 cm crack on the fuselage resulted in the in-flight breakup at the altitude of 10,668 meters, killing 206 passengers and 19 crew members. According to the ASC, the fatigue crack in the aircraft could be dated back to an accident that took place 25 years ago. On February 7, 1980, the aircraft suffered damage when it still touched the ground while landing in Hong Kong. Although the damaged plane was shipped back to Taiwan and underwent temporary repairs the day after the incident, permanent repairs conducted by the nation's largest carrier, China Airlines, were flawed. China Airlines did not repair the damage in accordance with Boeing's structural repair manual. The damaged skin should have been either trimmed or removed as the standard procedure required, but the repairs did not extend sufficiently beyond the damaged area and thus did not restore structural strength. The ASC believes that the pre-existing fissures on the scratch surface, and after not having been properly fixed, deepened and grew to a 180.34 cm crack as a result of pressurization and depressurization during flights. A crack measuring 180.34 cm in length is long enough to cause structural separation in the fuselage. It is the root cause of the in-flight breakup of the aircraft. Now, I will pass the time to Manish to cover the contributing factors of the cause.
Okay, thank you, Jaden. Okay, okay, thank you, Jaden. So now I'll be sharing with you all the contributing factors that led to the crash of China Airlines Flight 611. One of the main contributing factors that led to the crash of China Airlines Flight 611 was due to the improper maintenance after a tail strike incident that occurred much earlier. On February 7, 1980, the aircraft was flying from Stockholm Arlanda Airport to Taoyuan International Airport via King Abdulaziz International Airport and Kai Tak International Airport as China Airlines Flight 009. While landing in Hong Kong, part of the plane's tail scrapped along the runway. The aircraft was later depressurized, ferried back to Taiwan on the same day. A temporary repair was done the day after. Permanent repair was conducted by a team from China Airlines from 23rd May through 26 May 1980. Thus, the cause of the tail strike was one of the contributing factors that led to the crash of Flight 611. Next slide. Another contributing factor that led to the cause of the crash of Flight 611 was the way the maintenance company carried out the maintenance for Flight 611. After the tail strike incident, the permanent repair of the tail strike was now carried out in accordance with the Boeing Structure Repair Manual, also known as SRM, by the maintenance company. According to the SRM, repairs can be made either by replacing the entire affected skin or by cutting out the damaged portion and installing a reinforcing doubler plate to restore back the structure strength. However, the maintenance company from China Airlines did not follow the SRM. Instead, the China Airlines maintenance team carried out the maintenance even though the kind of damage inflicted on the tail was way beyond the damage that a doubler is meant to fix. The crash will not occurred if the doubler was installed properly, as the damaged skin was not trimmed properly and the repair doubler did not fully extend sufficiently. Beyond the entire damaged area to restore the structure strength, this means that all the scratches will be completely contained by the innermost row of fasteners, and the fasteners themselves will be strong enough to stop the propagation of any new and existing fatigue cracks. However, as the doubler install was too small and therefore failed completely and effectively cover the damaged area where scratches were found, and outside, the outermost row of fasteners were meant to secure the doubler. However, the installed doubler with scratches outside the rivets provided no protection against the propagation of any concealed cracks in the area between the perimeter and the row of rivets. After the number of pressurization and depressurization cycle during flight, cracks began to form around the exposed scratches. After 22 years on 25th May 2002, after the faulty repair was made upon the damaged tail, the hull of the aircraft broke open mid-flight. Explosive decompression occurred once a crack opened up, causing separation of the aircraft fuselage aft section 46. The remainder of the aircraft section 46 went into abrupt descent, resulting in the separation of all four engines from the wings. This initial breakup point remained connected until the impact with the sea. Thus, this was another contributing factor that led to the crash of China Airlines Flight 611. Next slide. Another contributing factor that led to the crash of China Airlines Flight 611 was due to improper operator maintenance inspection. After the maintenance team of China Airlines maintenance team have done their maintenance, the operator that was meant to inspect the maintenance done on Flight 611 did not detect the ineffective 1980 structure repair and the fatigue cracks that was developing under the repair doubler. If the operator found out about the ineffective structure repair and the fatigue cracks under the repair doubler, the crash of China Airlines Flight 611 would not have occurred. Now, I'll pass over again to Brian, who's going to cover about the analysis and discussion of Flight 611 crash.
Okay, thank you, Manish Aditya. Now on to the analysis and discussions. Based on the recordings of the cockpit voice recorder or the CVR and the flight data recorder or the FDR, radar data, the dado panel, open-close positions, the wreckage distribution, and the wreckage examinations, the ASC concluded that the in-flight breakup of the aircraft as it approached its cruising altitude was highly likely due to the structural failure of the aft lower lobe section of the fuselage. The ASC found evidence of fatigue damage in the lower aft fuselage centered about STA 2100 between stringers S48L and S49L, under the repair doubler near its edge and outside the outer row of securing rivets. Multiple side damage or MSD, including a 15.1-inch through thickness main fatigue crack and some small fatigue cracks were confirmed. Next slide. Residual strength analysis indicated that the main fatigue crack in combination with the MSD were of sufficient magnitude and distribution to facilitate the local linking of the fatigue cracks so as to produce a continuous crack within a 2-bay region about 40 inches. Analysis further indicated that during the application of normal operation loads, the residual strength of the fuselage would be compromised with a continuous crack of 58 inches or longer. Although the ASC could not determine the length of cracking prior to the accident flight, the Council believes that the extent of hoop-wise fretting marks found on the doubler and the regularly spaced marks and deformed cladding found on the fracture surface suggested that a continuous crack of 71 inches in length, which is a crack length considered long enough to cause a structural separation in the fuselage, was present before an in-flight breakup of the aircraft. The ASC found that a 15.1-inch crack and most of the MSD cracks initiated from the scratching damage associated with the 1980 tail strike incident in Hong Kong, which the repair was not accomplished in accordance with the Boeing SRM. As the damaged skin in that area was not removed but trimmed and the repair doubler did not extend sufficiently beyond the entire damaged area to restore the structural strength. Prior to the occurrence, the operator's maintenance inspection of B18255 did not detect the ineffective 1980 structure repair and the fatigue cracks that were developing under the repair doubler. Now, I will pass the time to Wei Xuan again for safety recommendations.
Thank you, Brian. Now we'll move on to safety recommendations, which me and Jaden will talk more about. Firstly, the CAL did not accurately record some of the early maintenance activities before the accident, and the maintenance records were either incomplete or not found. Before the first structural inspection in the 1998 MDV, the badge area was not clean. For safety purposes, the badge area should be cleaned before inspection to ensure a closer examination of the area. Secondly, ensure that all safety-related service documentation relevant to Republic of China, ROC, registered aircraft is received and assessed by the carriers for safety of flight implications. Thirdly, ensure that the process for determining implementation threshold for mandatory continuing airworthiness information, such as recovery, analysis and presentation system, RAP, includes safety aspects, operational factors, and the uncertainty factors in workmanship and inspection. I will now pass my time over to Jaden, who will continue to cover the safety recommendations.
Okay. Thank you, Wei Xuan. Now I will continue. Next, we should encourage operators to assess and implement safety-related airworthiness requirements at the earliest practicable time. Furthermore, we should closely monitor international technology development regarding more effective, non-destructive inspection devices and procedures. The Aviation Safety Council (ASC) also recommends that the Boeing company should reassess the relationship of Boeing's field service representative with the operators such that a more proactive and problem-solving consultation effort to the operators can be achieved, especially in the area of maintenance operations, to develop and or enhance research effort for more effective non-destructive inspection devices and procedures. Now, I will pass the time to Wei Xuan again to conclude.
Thank you, Jaden. All in all, the catastrophe could have been prevented if not for the engineers' lackluster maintenance. The tragic 225 fatalities could have been avoided if proper procedures had been carried out. We have come to the end of our presentation and we would like to thank everyone for their kind attention. We will now move on to the Q&A.